Well, hello. So, I've been getting a lot of comments on YouTube, and so we're gonna go. Well, we're not even gonna look at the comments because they're all the same. They're all the same. Excuse me. Whoa, I just about spilled my coffee right there. If you guys have coffee, take a drink of it. Oh yeah, that's good. Um, so here's what people say to me. You can't have two centers of rotation on a flat Earth of the stars. Well, that's easy to debunk. Have you looked up at the sky before? We're going to look at Stellarium. So let me, excuse me. Let me make sure that you guys can hear me first of all. Oh, it looks like you can. Welcome, Coffee House and Deb Woods and Roderick. Welcome. Um, let's see here. Let's go over to the desktop where I have Stellarium sitting there. And we are in Colombia. We are in Colombia. We're on the equator, or close to it. So, I just want to explain what I have on the screen here so everybody understands. We're looking north from the equator, almost the equator. See that star right above the N? That is the center star that all the stars go around. The pole star, whatever you want to call it, Polaris. So if we go like this, and if we go forward in time, we're going to see the stars going counterclockwise around that North Star, right? Very simple. Counterclockwise rotation. Well, all these comments I get tell me, and Craig from Fight the Flat Earth told me, no, at the equator, they switch directions. Well, I'm here to show you how simple it is of a misunderstanding. Okay, so we're just going to look at this again. We're going to go back to there, okay? So we're going to go forward in time. So like as time goes, the direction that time goes, and watch the stars going in a counter or anti-clockwise, right? Okay. So now we will simply turn around to the south and we will look. Now, going forward in time, just like time goes, we are seeing clockwise rotation. Do you see that? Are the stars going the same direction? Yes. Let me show you what I mean. Okay, let's look to the west. Okay, now as we go, let me skip back here. Okay, as we go forward in time, we're going to see the stars going down towards the horizon, setting, right? Setting in the west. No matter if you're looking north, they're still setting in the west. Or if you're looking south, they're still setting in the west. Even though they're going, from your point of view, they're going different directions. They're going opposite direction of each other. But that's because you turned around. Has nothing to do with the sky or anything about being a globe. So we're going to go around the world a little bit on Stellarium just so I can show this over and over again. So south from the equator. Whoops. Okay, so I better just hit this time button from now on. Okay, going forward, clockwise, looking south. Okay, clockwise looking south. We turn around to the north. Counterclockwise, anti-clockwise, whatever you want to call it. Looking to the north. Setting in the west. We'll turn to the east. Rising in the east. Okay? We're at the equator in Colombia. So now, here's where we were, right there in Colombia. Okay? So that's where we were there. Now we're going to go to where I live, which is in Minnesota at 45 degrees. And now we're going to look north again. Okay. Same thing. Anti-clockwise. Around the same star. But you notice the star's in a different position now. Remember it was right above the N before? When we were south farther? That's because how everything in the sky ever that's going away from you will appear to go down towards the horizon. As you go further away from it, it's going to get closer and closer to the horizon. Very much like a jet flying away from you. It's eventually going to run into the trees, and then you won't be able to see it anymore. This is very much the same of what Polaris is doing here. Is we're closer to Polaris now than we were in Colombia. Anti-clockwise, okay? Now we simply turn around to the south, and what do you expect for us to see? I expect us to see the same thing again. Clockwise is what I expect to see. There we go. Setting in the west, rising in the east. Okay, now let's go somewhere south. Let's go to... The last time what I did is I went to Fiji. So we'll just try that. Fiji. Let's just zoom out to see where we are. Whoops. So that's a little bit... We should go further south. We should go further south. What's down here? Argentina. Let's go to Argentina. Okay, and we will use this location because that's further south. All right. What do you expect to see? I expect to see the exact same thing. Anti-clockwise in the north, clockwise in the south. So here's the south is moving clockwise around a point right about here. There's not necessarily a bright star there, but there's a center point, right? There's an axis. There's a center of rotation, but it's clockwise. Now I simply turn around to the north and anti-clockwise. Setting in the west, rising in the east. No matter where you are in the world, this is what you will experience in the sky. So let's go to the North Pole or the South Pole, but the North Pole, because there's a star there. And it's not exactly perfectly centered, but it's very close. Let's see, what do I got to do here? I have to go to this button. I don't know what I'm thinking. Okay, so let's go to the North Pole. The North Pole. 90 degrees, right? Use this location. Now what do you expect to see if we look north? What we actually expect to see is if we look directly up at zenith, we will see Polaris. So let's do that real quick. Okay. And which way do you think it'll spin? Anti-clockwise. Okay. Around Polaris, same star. I'll zoom in so it says the name of it. Polaris. See that? Okay. So now, what way do you expect it to go? If we look north, what do you expect to see? You'll actually see the same thing all the way around. Let's see. See that? We're not looking up directly into the sky, so we're not seeing Polaris. Everything is going around Polaris. So then as we move south, we get Polaris gets lower and lower in the sky. And then when we get to the equator, we have to turn around in order to look south to see its center point of rotation. So when we're looking south, we're actually looking the opposite direction as we are when we're looking north. So anywhere in the world, you're going to have the same thing in the south as you are in the north, but it's going to appear to be a different direction. It's still going to move if you're at the south, or if you're anywhere close to the South Pole or anywhere in the southern hemisphere, or whatever you want to call it. The stars are going, if you're looking at the center of the axis of rotation, the stars are going to appear to go clockwise. So, pretty simple. Now, in the description of this video, let me see if I can find it. And this isn't going to be a very long video, but I said, also, let's talk about this, what the stars tell us about the shape of the Earth. What do the stars tell us about the shape of the Earth? Absolutely nothing. See, here's where I'm at. Maybe we're gonna go to my YouTube. Or let's go to YouTube. I was thinking of Facebook for a minute, but I just want to read you some comments that I've been going back and forth with some people and give you an understanding of what they're thinking. And it's not right what they're thinking. They're in error, and it's easy to point it out. Let's just go to my channel, I guess. Hey, if you guys aren't subscribed, subscribe. Okay, let's look here. I just want to... CC is a video I watched and commented on, and then people started coming in and commenting or replying to my comment. So, here we are, 20 replies. I just want to show you some of these. Okay. Hey, effed up, figured out an equatorial mount only works on a globe yet? Not true, Stonemason, sorry. I'm actually, right now, the moon is up in the sky, and I'm actually tracking the moon with one axis on my equatorial mount. It's not that difficult. It's simple geometry of a circle. A circle is a shape where the radius is the equal length all the way around it from a center point. So it's a circle. That's what shape it is. So Stonemason lives in Australia. Might be a bit tricky. Is that when you will admit you are wrong? And I said, wrong about an EQ mount? Just point at the only axis of rotation you can see in the sky. It will be south of you, because he's in Australia. And then he said 2 points. One, if the Earth was flat, the stars would only rotate around one celestial pole. They don't. Actually, they do. They rotate around the north. And you could almost say that about the south, but there isn't really a star there. So that's why I say the north. And I'll explain that again with Stellarium in a minute. They rotate here in the opposite direction to you. No, that's because you're facing a different direction. You're facing south. I'm facing north. Have you guys ever taken a picture of the moon when it's rising and then taken a picture of the moon when it's setting? Did you notice it's upside down when it's setting? Is the moon really upside down? Or is it that you had to turn around? It's that you had to turn around. It's like drawing... in my office out in the garage, I drew a number 6 on the ceiling, so that if you look at it from one side of the room, you will see the number 6. And if you look at it from the other side of the room, you will see the number 9. But it's still written the same. It doesn't have to turn or anything. It's perspective. It's the direction you're looking at something from. It makes it appear a certain way. This seems to be a problem with people that are living on a globe. They think that the stars are going to prove something about the ground that we're all on right now. That is, as far as every perception we have, is stationary, not moving. It moves during a landslide or during an earthquake. That's all. And to say that you can measure the rotation of the Earth with an instrument that, first of all, measures light, or even a mechanical gyro, or taking a weight and a scale to different parts of the Earth and getting different measurements, this does not prove anything about anything rotating. You can predict whatever you want, but it doesn't mean that it's rotating. It has nothing to do with rotation. Or like a pendulum, and like a pendulum day, and all these, the math that gets done, and it's just ridiculous. Because it's almost like superstition. It's almost like, yeah, well, if we predict this and we get a measure or a number that's within 10% of it, it's got to be right, right? I mean, there's way too much guessing going on. I was watching a video earlier about the James Webb Space Telescope, and they're calling it a time machine. That was on the Vice, I think. These people are losing their minds. What they're saying the mirror on this telescope is so smooth that if it was the Atlantic Ocean, the biggest, error in the mirror would be 1 inch in the whole Atlantic Ocean, 1 inch high. And I'm like, you can't do that. You can't even say that. It's just a ridiculous thing to say. Basically, they want you to feel that they have gone to such far lengths. First of all, really, because they're getting your money, and they know that. So they have to put on a show that they're doing amazing things. But really, they've spent $10 billion on this telescope, and it still hasn't launched. And they started it in, I think, 1996. 25 years to build a telescope for $10 billion? Sounds to me like an easy cake job. That's what it sounds like to me. A nice long-term couch to sit on. That's what it sounds like. But they want to do it, you know. So then let's see. He says you need to ask yourself if. Or wait, I didn't get to the rest of that. He said they rotate here in the opposite direction. No, they do, but they're all going the same direction. They're all rising in the east and setting in the west. All the way in the south and all the way up to the north. So if you follow, like, let's say the first star out from Polaris is doing a circle, right? It's doing a teeny little circle around Polaris. And that's the circles we can see, those are circumpolar stars, where you can see the entire circle, like on the thumbnail of this video. Actually, oh yeah, you can see the thumbnail right here. It's on the screen right now. But the ones that you can see the full circle on, those are called circumpolar. And then as it goes out from that North Star, as it goes out, each star continues to make a different circle around Polaris, all the way down to the south center of rotation. So if you went down to the south and you took one of those stars and you tracked it, it would do a circle around that south point of that south axis of rotation. But what is it actually circling around? It's circling around the north, and it appears to be circling around in the south. It's just I'm guessing it's much farther away, but I don't really know that. But I know what we observe. We observe certain things from the Earth, and there's a way to understand that. And then there's a way to make a bunch of assumptions that are false about the opposite of the sky, which is the ground, which has nothing to do with the motion of the stars. And so that assumption is just killing people's understanding into what this world is. It's sad, actually. But he says Okay, they rotate here in the opposite direction too. Also, the moon and constellations are upside down here. Yes, they should be. If you stand, like I was saying with the 6 on the ceiling, if you put a nickel on the ceiling or whatever, tape a nickel on the ceiling and look at it from one side of the room, it's going to be upside down from the other side of the room. This is not difficult to understand. I mean, it's literally because you moved, you turned around. That's why it's upside down. So that's why all that, the moon and everything looks upside down in comparison to the north. Okay. And then he says, number 2, an EQ mount would have to move in 2 axes to track on a flat earth because the object would change position in both height and distance. No, that's not true at all. You can go anywhere in the world and you can put an EQ mount with 1 axis on it. That's what an EQ mount is. It only needs 1 axis. And you point the center of that axis that the telescope moves, you point that center at the center of the axis of rotation in the sky. And if you're in the north, you have to have it set up for the north because you're looking north. But if you're in the south, you're going to have to go into your settings in your telescope and you're going to have to change it to south because it's going to know that it's turning around and it needs to go the opposite direction in order to track the stars. So if you the cheap mount that I made, the remote actually has a screw in the back that you switch the screw to the other side for north, and you switch it back and forth. So that's how it works. But so that's what I'm using right now, tracking the moon. But says nothing about the ground. You can stand on, a hill or a mountain and set up a telescope there, and it's the same as if you set it up in a valley it doesn't matter the shape of the ground. It has nothing to do with the shape of the ground. If it did, I would like someone to tell me how. Because this is what I'm hearing. This line right here. An EQ mount would have to move in 2 axes to track on a flat earth. No, it would not. Why would anybody even say that? That doesn't even make any sense. Everywhere you go, you can look up at the sky, whether it be in the north or the south, and you can find a center that the stars appear to be going around. You only need 1 axis of rotation because you're just following the sky. You're just turning along in that circle with the sky from anywhere you go. You can point it at Polaris from anywhere in the north, and you will get circles going around Polaris. Doesn't matter your height or your distance. That's why some of the videos like Red's Rhetoric made make no sense. They're taking places on the ground, getting the latitude angle to Polaris, and thinking that that's supposed to give them a distance to something. No, you're just pointing your it has nothing to do with Earth's rotation or anything. That's all just an assumption. That's all wrong anyway. The sky turns, and actually we'll look at I don't know if you guys saw it yet. Some of you did, I think. A community post that I just did today aimed at Craig from Fight the Flat Earth and Red's Rhetoric and MC Toon. I gave them measurements and math. Well, it's very simple math. But measurements of the sky turning that 7.5 billion people observe. And so I wanted them to give me their measurements of the sky not moving. Because MC Toon has asked me before, well, give me measurements of the flat earth. Like measurements of it being flat. And I'm like, how do you do that? So you guys give me measurements of the sky not turning. And then that's how I feel about the other way, Oh, okay. So I'm just going to read a couple of these. You need to ask yourself, if the earth is flat and the stars are rotating, what should someone in the southern hemisphere see, or what should someone at... You don't think I ask myself that, Stonemason? Oh boy. See, here's another problem is that these people are coming at this as if I never thought about it before. And that's where they're all wrong. I bet you I've thought about it more than they have. Not that I know everything or something, but I make an observation and I'm not going to throw it away. Like the room you're in right now, the floor, not moving, not spinning on an axis, not rotating. That I know. Yet they'll tell me that they're observing a rotating Earth. I'm like, no, you're not. You're actually lying. You're not observing a rotating Earth. The measurements you think give you proof that you have a rotating Earth are probably not accurate because you're sitting on a stationary Earth. Like the idea with the scale, if your weight's way different in different places of the world, what do you have to set your scale on in order for your scale to be accurate? You have to set it on very stable, solid ground, or it won't be accurate. So you kind of contradict your own measurement, you know? That's the way I see it anyway. And let's see here. The Earth is not flat, he says. Tim A. Arguments don't prove shapes. Measurements do, though. We are waiting. Measurements? Oh, that's what I was asking. Haven't you seen star trails from stellar rotation around the south celestial pole? If you're in Australia, you can capture those for yourself. Baryon, yeah, but that is the center of rotation in the south, looking south. If you turn around, you will notice that the stars continue to go in the same direction around the North Star. I am making a video to explain this better. Ding! We're watching it, or we're on it. Facing south, all the stars will appear to be going clockwise around that axis of rotation in the south. Facing the opposite way, looking north, all the stars will appear to move counterclockwise around the axis of rotation. The problem here is that you think that there's people living upside down in Australia, so you're out of your touch. You're out of touch. You're living in a false reality, so you can't even picture north and south. They're two different directions, you know? It should be simple, but and I said star trails look very similar when facing north or south, but the rotation will be the opposite each way. The stars rise in the east and set in the west everywhere. So then Stonemason says, why do you not understand this? If you lie on the floor and look straight up at the pole star, the stars move from left to right in a circle, right? Yes. That circle is anti-clockwise, right? Yes. If you lie on the floor at the equator and look up at the stars, pass in a straight line east to west, look up at the stars, pass in a straight line east to west, right? Yes. If I lie on the floor and look straight up, the stars move left to right in a clockwise direction. I think he forgot to put north in there, but I don't think that we disagree. I don't think we disagree at all, except that I'm pointing out that the stars aren't moving rotation. It's you turning your head around that is moving the rotation. And yes, you're looking straight up in the south at the South Pole, but you're not at the South Pole. So no, they're not moving in that exact. They're not moving in that way where you are in Australia. They are moving clockwise around an axis, around a specific part of the sky. They're moving in circles clockwise. And if you turn around clockwise down from the south, then it does from the north. You're turning the direction you're looking has changed. You're looking the opposite direction. So this should show you that anything above you is going to be upside down. I mean, do a look at the ceiling and I don't know, tape something up on the ceiling and just walk to the other side of the room, and it's not It's just it just happens. So I'm not gonna read through all these comments, but so listen to what I'm saying, please. They just think that I don't understand something. Okay, I didn't see this comment, I don't think yet. I do see it. You're just trying to make excuses for what I see and the other 800 million people see in the Southern Hemisphere. No, I know what you see in the Southern Hemisphere. There's no conspiracy here, Stonemason. Tell me this, where should the summer sun rise and set for me on the south coast of Australia if the Earth is flat? Well, first of all, the Earth is flat. And it's going to say nothing about the ground, okay? It could be, the ground could be concave. I don't understand why they think they know what the flat Earth looks like or something. That makes no sense. By the way, welcome anyone who, I see a couple new names in there. Welcome. Okay, so that was that was good enough for that. So let's go back to Stellarium. And I forgot what I was going to show you in Stellarium. Okay, Martin H. just commented. I got to read this one. Oh, yeah, that's what I was going to do. Is I was going to read this community post that I made for Fight the Flat Earth. Red's Red. I showed him this picture. Okay. Ooh, I don't know if my... Yeah. Oh, okay. Something's wrong with my playback or whatever. It's not playing back. Oh well. Let's see here. Okay. Here's a measurement of the sky moving. Here's an explanation. Please show your measurements of it not moving. One measurement is done by taking a camera from the Earth where we live and taking a long exposure time lapse of the sky. What is observed every time this is performed is that we see the stars circling around a specific part of the sky. Each star in the sky that is circumpolar is visible above the horizon, making a perfect circle around that specific part of the sky. We call this an axis of rotation. Each star in the night sky is circling around this axis of rotation, which is observed from the Earth no matter where you are. Stars rise in the east and set in the west on the whole Earth. This shows us that they all circle around the north axis of rotation in the same direction, even to the south axis of rotation. Turning around at the equator to look the opposite direction from north to south makes the stars appear to be going clockwise, and turning around again to the north, they will appear to circle counterclockwise or anti-clockwise. Each circle is 360 degrees of motion each day. Then I said, please show me your measurements of them not moving. So I'm waiting, guys. I want to see it. I want your measurements. So then I wrote, after this I want to talk about why a rocket has to accelerate to orbital velocity to stay in space. And then I got a little serious. I said, I'm trying to warn you guys that it is not what we have been believing our whole lives. It is outer darkness where there will be weeping and gnashing of teeth. You are being deceived, and I want you to see the truth. I welcome any of you to come to my channel for a discussion about these topics. I've had fun debating, conversing about these things, and want to challenge some more of these things with observable truth that has been kept hidden from mankind until now. Hit me up. And I'm serious. So then let's read this comment here. That's a long one. This is frustrating because you're clearly not an idiot or mad, Joe, but you're looking at exactly what shows how the Earth works within the universe, but coming to a conclusion that turns reality upside down. No, it's actually not at all. I'm actually opening your eyes, trying to open your eyes to the actual observations you make. I mean, I sat and debated Red's rhetoric for like 2 hours on whether the stars were moving or not. He wouldn't avoiding your own reality. You're looking at anything but your own reality, where the stars are moving above the Earth for every one of us. Okay, it's like poles simply cannot work on a flat planet. It's not a flat planet. It's the thinking. You have a telescope, and I presume that it's good enough to show you The surface, watch them rotating. So you have me completely puzzled. As for observable truth that has been kept hidden from mankind until now, at best you've just got a new spin on something that humans last believed en masse in the time of the ancient Egyptians. Humans used to believe all sorts of weird things, but over the last few thousand years, various brilliant people... No, these people weren't brilliant. It's actually that we have better equipment more widely available to average people like me. So you have a lot more people in the world that are testing and observing things. And so you have those people that are testing and observing things, and they are opposed idea is, and so the world's fighting back. That's what this is. But we have, like I was saying in this post, the stars move. The whole sky moves at a super fast speed. Anything coming in from this, let's see. Sometimes at the risk of their own lives, we should be grateful they were in. But like I said, we have equipment that we didn't have. We have optics and things that we didn't have access to on like the average people didn't. These things. And I'm sure that you've cooked up some sort of alternative explanations, but I genuinely wish you'd realize that you can still have your deep faith and at the same time acknowledge the true mind-boggling awesomeness of the real universe. There's no universe. There's the earth, and the earth has a heaven above it, or many heavens or whatever. There's heaven above the earth. It's this earth is. If you look up there, there's no physics the same as the earth. Not at all. There's no air. There's no water. There's no land. There's everything there is in a state of free fall, falling around something else perpetually. The speed that it's going, orbital velocity or better. Like, just think about some of these things. Hey, I'll give this guy a heart, though. Nice comment. I appreciate it. Think you're never going to understand it. You know, Chris Chispack, that's a good point. He says somebody needs to build an optics that measure the magnetic field of that rotation because the light is coming from the magnetic field in the waters above. You know, that's when I see a drift from a gyroscope or from a ring laser gyroscope, that's all I think of. I just think of all the things that we know happen, like magnetism, and you know, we don't know anything about them. We have our ideas or theories about them, but if I asked you why your compass physically points to some place in the north, you couldn't tell me why. That's what I'm saying. You couldn't tell me why. I couldn't tell you why. I could tell you my theory is that there's a mountain there or something that's magnetic, that attracts, that has that magnetism. It's simple. That's what I believe. Other people come up with theories about magnetic fields in the north and the south, and the whole earth is, yeah, that's not what I believe. But, yeah, Flat Earth Space Agency says, like, space brimstone, like a witch has just been there. That's a quote, by the way. So, yeah. Let's see here. Let me, for all those people still not convinced, let me see if I can convince you a little bit. If I can convince you a little bit. And then actually I'm going to play a video, a couple videos maybe. I'll play the video of me and Red's rhetoric, or whatever one I can find, or me and Craig after this.
But we're going to talk specifically tonight about the rotation of the Earth. Is it a thing?
So this was this is just some clips from a recent debate I was on with Craig. And if you pay attention here, all he wants to do is deny his own senses.
Of course it is. Thanks, Bob. Joining me to have this discussion is Effed Up World. Effed Up World, how are you?
Good, Craig. How you doing? Thanks for having me again.
No worries. Thank you for coming on. I love the dumpster fire thing behind you there. So when before I joined the Navy and when I joined the Navy, we talked a lot about how to navigate using the stars in case we ever got lost, and to understand where we came from as sailors to where we are. And one of the big is that they move in a particular way. They move in a particular way. They move in a particular way.
Yes,
And
you just said it. I agree.
yeah, now, but the thing is, when you look at the way they move, look at the way they move, look at the way they move, they move. That, to me, explains what we are seeing because we are rotating. That gives me the personal observation that we are on something rotating based on the position of things that we are seeing in the sky as we rotate. When you map out the positions and the way that they move through the sky, it only makes sense when you're on a globe. It was very obvious that the Earth was the thing that was rotating based purely on the movements of the...
It, uh, if we were to look up at the stars and they appear to be moving, like you said,
Look at the way they move. They move in a particular way.
and the constellations move throughout the year and each night, but we could also look at that and say, well, maybe that's the Earth spinning. And so if the Earth is spinning, then to stand that, and I don't deny that, and I do acknowledge that that's a possibility, because that, like you say, it does make sense. But there is a basic observation that we all make our whole lives living on the Earth. We all live here. So if, I guess I don't know what the right words are, but by definition, if we look up at the sky and we see the sky moving, then it would appear to me that the sky's moving.
We don't sense that the Earth is moving because we're not...
Observe a still floor in the room. Did you guys hear what Craig just said? What he said, but let's go back and check it out.
sense that the Earth is moving because we're not designed to sense that the Earth is moving.
This just shows you that everyone knows that there's a God, and some people are just running from him. Stop running, Craig. And so two simple things. I observed a still floor in the room, just like the room you're in. The floor is, as far as you as a human being can tell, the floor is not moving. And then when you look up at the stars, we know that they are moving from the standpoint that from our bodies where we live on the Earth. Well, I have a hard time ignoring the observations that everybody has made there for 24 hours a day their entire life. Why do we need to, in order to go into space, why do we need to move so fast to stay up there, I'm saying?
To avoid hitting the ground.
Okay, and so saying that you agree that anything that's in space or whatever you want to call it is moving at orbital velocity or better, right?
That's why we have to test things. And
yeah,
Joe, there isn't
let me give you an
test on your side.
Let me give you an example of a test. Let me give you an example of a test.
Please do.
And I'm not trying to be disrespectful or something. I'm literally trying to tell you of a legitimate thing that I can do, and I brought this up when I was debating Reds, is when we do long exposure photography of the sky, I don't think you would argue with me that what we find in the viewfinder is that the sky is turning and that my camera's Earth in one spot. I'm saying from here anyway.
Well, all the bits that were sent up to construct
the delta
it,
V that it has is relative to the ground, right?
Yeah.
The orbital velocity, I'm saying. If we said it was moving 17,000 miles an hour, that means it literally covers that much ground in an hour, or 5 miles a second, or whatever it is. I don't remember. But that's the space station. So sort of the opposite way of saying it's we could be on the ISS and look down at the ground and see it rotating, or we could be on the ground looking at the ISS saying, well, we're on the still ground and the ISS is flying over at a high velocity. We could talk about physics. There's a different kind of
It's
physics.
the same everywhere in the universe.
So everything, like on the way to the moon and on the way back, they were free falling, zero gravity. And have here for physics on the Earth.
No, what do you mean anything
not,
that's ever been in space
but
in
you
zero
have to-
gravity? 88% of the gravity we
So
do
is the
here.
moon, and so are the moons of Jupiter, right?
Yeah.
And so is every satellite, and everything that's ever
But
been
they're
in
so
space
big,
is
they've got
free-falling.
their own gravitational field that will affect us enough. But the
you
none
know
of
what I'm
this
saying,
changes. Come on, dude. Right, let's just stick with facts and measurements, not personal opinion.
Craig, you know this.
What do I agree with?
You know that anything that is not on
If,
the Earth
if it's in
is
orbit,
moving.
if it's in orbit, it has a sum of
Everything
zero
in space
vector
is in
acting on
orbit.
it.
Everything in space is in orbit. Do you agree?
Well,
Around
it can
something.
be in orbit of different things, but it could have a vector
Yeah, but-
separate to that. But if anything,
So everything
let's
in
just go with
space
Earth.
is
Let's just go with
free-falling.
Earth. Let's just go with Earth, right? Anything
Okay.
in orbit around Earth has a sum vector of zero acting on it at that point. It still has gravity acting on it, but because
Yes.
it is also has a tangential velocity that it does, it is technically free falling, which counters the gravity that it's got. So it has a sum vector of zero.
What I can show you, like physical things, like what happens anytime something goes from space into the Earth? What happens? Even if it
mean when-
survives, there's
you
a
mean when it
huge
deorbits?
sonic boom. There's a sonic boom. Yeah, like when it deorbits.
Or
Is it buffering for you guys? It says I have an excellent connection, so I don't think it should be. Maybe if I've noticed a couple people in the chat have said that they are experiencing buffering. Do you guys want to let me know if... Oh, Deb Wood said buffering too, and Veronica no. So, I don't know. Debating with Red's Rhetoric right after this. Talking basically about the same thing. And they're just sitting denying reality the whole time. And then also, kind of a fun video that I made after that, talking about similar things. So I just think it's an important thing to understand that there's a different way to look at the world we live in than there was before. And I didn't come up with it. It's being shown to people, and this is important. There's a
comes
sonic
into the
boom, right?
atmosphere.
What's that?
It comes into the atmosphere.
Some of them up by having you agree with me.
But
If-
I
if
don't
it's
agree
something
with
you
you
agree with.
about. But I haven't agreed with any of the physical things that you say because they're all very, very
Okay,
wrong.
so... Okay, maybe I'll just have to... I see there's quite a few people in there saying it's buffering. But not when I talk. So maybe that's something wrong with... That could be my program doing that. So I'll probably just not play videos, and maybe I'll come back on and play these videos or something. But yeah, that was mainly what I had to say. Is I just want these guys to understand that they're ignoring the biggest observation of the Earth being stationary, because there's 7.5 billion people observing this every day, and these guys want you to take the when everybody in the world observes a world that's not turning. So I'm out here, guys. Thank you, and